Hey guys, got some notes for us on rational expressions. That's going to be what we're getting into this week. So anytime you see rational expression, okay, think fractions. You know, the word ratio has to do with division. It's what we get when we divide two numbers, a over b, right? So really, we're just taking two polynomial expressions. I can think of that as p of x and q of x, where both are polynomials, and we're dividing them by each other. So, you know, for example, we have ax squared plus bx plus c over something else. I don't know, dx plus f. Okay, could be as silly as that, or it could be something as simple as 1 over 7 plus x. You know, really anything where you have one polynomial divided by another. Okay. Another piece of information that we have to think about with our work today and the rest of this week is something called excluded values. So, you know, we talked about when you have fractions, you can't have 0 on the bottom, you can't have 0 in both places. You know, both of these things are not allowed. So excluded values are anything that would make the denominator, which remember is the bottom of the fraction, anything that would make that 0. Okay. Also anything that would give you 0 over 0. All right. Now, how do we find excluded values? So the way we're going to do that is we're going to factor both the top and bottom. Okay. And we can determine what makes the bottom 0 by setting it equal to 0 and solving. So, for example, let's suppose we had something like 1 over x squared minus 4. Okay, this is a rational expression. Now, we can factor the top and bottom. Top is unfactorable. We can factor the bottom, though. It's a difference of squares, right? X plus 2, x minus 2. And so we ask ourselves, you know, what could I plug into the bottom? What could I plug in for x that would make the whole thing 0? Okay, and if we remember, anything times, you know, any number, 0 times any number is always going to be 0. So we just want to see, you know, we only need one factor to be 0, right? So if x plus 2 equals 0, that means we were plugging in negative 2. If x minus 2 equals 0, you know, we get that by plugging in positive 2. So our excluded values here would be negative 2 and positive 2. And I'm going to put them in squiggly brackets because I'm feeling fancy. Okay, so, you know, let's talk about, in general, how to simplify rational expressions. And then, you know, what to do when we're multiplying or dividing them. So the first thing you always want to do is, you know, you always want to factor first. Okay, factor first because, you know, if you can find things that cancel, it's going to make your life a lot easier. Okay, so factor. If we need to identify excluded values, we will. Then we're going to look for terms that cancel out. Okay, if there are any. Right, and then we'll get into whatever we have to do, whether it's multiplying or dividing, adding or subtracting, etc. And, you know, remember, these are just fractions, so they follow the same rules, right? When I add fractions, when I add or subtract fractions, I need a common denominator, right? and we're going to get into that probably tomorrow. Right? When I multiply fractions, I just go straight across. Right? And then when I divide fractions, we have to remember what we do when we divide fractions. What is it that we do? That's right, we flip the fractions. So we keep the first. So if we're doing, a over b divided by c over d, we're going to stay, change, flip. So keep the first one, flip the second one, and then we'll multiply. Okay? So let's do some examples. Okay, looking at the first one, looks like I have to definitely factor the bottom first. All right, I'm going to do this up here where I have a little bit of space. So let's factor the top, the bottom. Okay, what multiplies to 8 and adds to 6? Well, that would be 2 and 4. Okay, so let's think about what our excluded values would be. Our excluded values are what we get when we set these bottom factors equal to 0, right? So my excluded values would be if p was -2 or p was -4. Now that we found the excluded values, we'll go ahead and cancel out. So I have a p plus 4 on top. I have a p plus 4 on bottom. Cancel, cancel. What I'm left with is 1 over p plus 2. So even though this simplifies to 1 over p plus 2, okay, I still can't plug -4 into it because originally, in the original version, it would cancel out. All right, let's try this one down here. So the first thing I want to do is I want to factor. It looks like on the top I can factor an a, and they're both even, so I can factor a 2a out of both. So I'm going to take 2a out of the top. What am I left with? A plus 5. I think I can take a 3a out of the bottom. 3 and 15, both divisible by 3. They both have an a. What am I left with here? I'm left with a plus 5 again. Okay, so what would my excluded values be? Well, if I set 3a equal to 0 and divide by 3, I get a equals 0 over 3, or 0. And if I set a plus 5 equal to 0, move that 5 over, I get -5. So my excluded values here would be 0 and -5. Okay, and an easy rule of thumb here is, if you factor out a variable by itself on the bottom, you'll always have 0 as an excluded value. I just need to plug 0 in for a here, and it would, kill off everything on the bottom. Let's go ahead and cancel out. So I have a plus 5 on top and bottom. They'll both cancel. I have a's on the top and bottom. They'll both cancel. And it looks like what I'm left with at the end of the day is just 2/3. Pretty cool how something that complicated can simplify to just 2/3. All right, let's do a division problem, and that'll be it for us. You guys can do the rest of these on your own, in class or whenever. Okay. So when we divide fractions, right, we want to flip. Okay, we want to flip the second fraction. The first thing I'm going to do is I'm going to try and factor this second one, see if anything cancels out before I go flip and before I multiply. So let's see. Okay, if I factor the top, 6 times 6 is 36, and 6 plus 6 is 12. So I have x plus 6 squared on top. On the bottom, 7 and 42 are both divisible by 7. I have an x squared that I can take out of both terms. And if I divide both terms by 7x squared, I'm left with x plus 6. Okay, so what would my excluded values be here? Well, if I plug 0 in here, I get a 5 over 0. If I plug 0 in here, same thing, I get some number over 0. If I plug -6 in, I get 0 over 0. So we can't plug in -6. Okay, let's see if there are any more, later on. So hopefully you notice there's some cancellation here. I have one x plus 6 on the bottom, and I have x plus 6 squared on top, so we'll lose one of the ones on top. All right, and now we're left with, let's see here, 5 over 7x squared divided by, now I only have one copy of x plus 6 now. I'm going to keep those parentheses around it just in case. And I have a 7x squared on the bottom. Okay, now that we've simplified a little bit, let's go ahead, let's flip our fraction, and let's multiply through. So when I divide fractions, I'm going to flip the second one. I think I can write that a little neater for us. Okay, we're going to change this to multiplication. We're going to flip. Oh, and what do you know? I have some more cancellation that's going to happen when I multiply through. I have this 5 and the 7x squared on top. I have a 7x squared on bottom, so those are going to cancel out. So all we're left with is 5 over x plus 6. And that's it.